Hi everyone. We are going to continue off of and what we were learning yesterday about hypothesis tests and build on some more vocabulary words like finding the p-value and making conclusions so we can understand how to actually take the information that the test statistic gives us and make our conclusion about our two competing hypotheses that we were writing yesterday. Today, our first example deals with tennis player Rafael Nadal, who has been called the king of clay for his excellent play on clay surfaces. But does he really have a greater ability to play tennis on clay courts compared to other surfaces? So the two-way table off to the right compares his wins and losses and what surface he was playing on in his matches in 2009 2010. So you can see in the grand total he played a total of 162 matches this season, these two years. So we're going to use this information and kind of review what we learned yesterday about stating hypotheses. So our null hypothesis, remember, makes a comparison for our player that they have the same ability in two different contexts. So in 2009 and 2010, remember, it's always important to include the year because how a player does in one year can be completely different than how they do in other years. So in 09 and 010, in 09 and 10, Nadal had the same ability you could say his ability to win or his ability, here they specifically say to play tennis, but if you said to win because we're comparing wins and losses, that would be fine too. On clay courts as well as other surfaces. So on clay and other surfaces. So that's what we're going into our hypothesis test assuming is true. Now, what are we trying to prove? Well, we're trying to prove the alternative hypothesis, which is that he actually has a greater ability to play tennis on clay courts. So, in 09, 10 seasons, Nadal has a greater ability to play tennis on clay surfaces. Rather than other surfaces. So our test statistic here is going to be the difference in winning percentages clay minus other. So how am I going to calculate that? Well, how did they do on clay surfaces? He won 44 of those matches out of 46. So in order to figure out that winning percentage, it's going to be 44 divided by 46 minus, how did he do on other surfaces? So 92 of them he won out of 116. So minus 92 out of 116. So if I type that in, you can type it in all at once and just make sure you have parentheses around your fractions. And we'll just round to the nearest percentage, so we'll just go to 0.16 or 16%. So just make sure you have parentheses around each fraction. And be able to use proportions or percentages. So our test statistic here is The name of our test statistic is the difference in winning percentage, and its value is going to be the 0.16 or 16%. So this part's new. A simulation was conducted to show the distribution of the test statistic to find out the various differences in winning proportions that could happen by random chance. 100 trials were conducted. So remember, this dot plot has 100 dots, okay, to find the values of the simulated test statistic for each trial, and they were recorded in the dot plot shown. So, describe what information this dot plot provides. So look at the label on the dot plot to help you know what it displays. It displays the simulated difference in winning percentage. So the dot plot displays the simulated difference in winning percentage clay minus other that are likely to happen by random chance. Okay, because it's not always going to be a difference of 0. The ones that are likely, given he really has the same ability on any surface, this is what's likely to happen by random chance. So the simulated difference in winning percentage, I should say percentages, that are likely to happen by random chance. Given his ability is really the same on all surfaces. Because remember, we're always assuming our null hypothesis is true, which is that he has the same ability on all types of surfaces. So this is what's likely to happen if this is really true and his ability is the same on all the surfaces. So we really want to see how special is this 16% here. So to do this, we are going to calculate what's called a p-value. And P stands for probability. So p-value, how likely it is to get a test statistic at least as extreme, how likely it is to get a test statistic at least as extreme, so meaning in this case that value or higher, as the observed value by random chance. So, how do I calculate my p-value in this case? My p-value is going to be the number of dots greater than or equal to 16%, because you're looking at least as extreme as the test statistic. Your test statistic was the 16%, so that value or higher, so it's greater than or equal to the total number of dots. And remember, in the description of the dot plot, it tells us there's 100 trials, which means there's 100 dots. Okay? So the results of the simulation provide an estimate of the p-value. according to the law of large numbers, we could only get our true p-value with an infinite number of trials. Okay? So let's find the p-value. On the next page it says let's find the p-value for the Rafael Nadal problem. Okay? So remember, we use our test statistic to get our p-value. So where was our test statistic? Our test statistic was the 16%. So here's 0.1, and then here's 0.2. Sorry, this says simulate difference in winning percentage, but these are listed, these are in proportion. So just think 0.16. So it looks like this dot is right at 0.16 because we'll look at that value and higher. Okay, that value and higher. So how many dots are at that value at higher? That would be 1 out of the total number of dots, which is 100. Okay, so our p-value here is going to be 1 out of 100, which is 1%. So interpreting the p-value, this is going to be a template that you're going to want to highlight, box, star, okay, that we are going to reference throughout this course, okay? So how do I interpret? What does this 1% mean? It means there is a 1% chance of getting, well, we insert the type of test statistic. Use the label on your dot plot for the type of test statistic of getting a simulated difference in winning percentage of what value did we look at? Well, we looked at, remember, this line right here was our test statistic. So we looked at, what was our test statistic? Of 16% or higher by random chance. Okay, and remember, that dot plot was assuming that he really has the same ability, that given the null hypothesis is true, is that he has the same ability on any type of surface. Okay, so you don't need to write assuming HO is true. It's just kind of noting that. So that's interpreting the p-value. That's definitely going to be on your worksheet tonight, so make sure to highlight that. So now, last step for our hypothesis test is making the conclusion. It's the reason why we do the hypothesis test. So if your p-value is less than 0.05, okay, or 5%, we do have convincing evidence to support our alternative hypothesis in context, okay? So if it's unlikely to happen by random chance, because it's less than 5%, so if it's unlikely to happen by random chance, yet it actually happened, well, I'm thinking they really do have a greater ability in one context or the other, because it's unlikely to happen, but this actually happened to Nadal. Okay? Now, if your p-value is greater than or equal to 5%, if your p-value is greater than or equal to 5%, we do not have convincing evidence to support HA. Okay, so if what actually happened is likely to happen, then you know what? It's not special in any way. It's likely to happen by random chance, so I really don't think he has a greater ability in one context versus the other. So remember, we always reference HA in our conclusions because it's like a judicial trial where they always say the defendant is not guilty. They don't say they're innocent. They always reference HA. Okay? So keep that in mind. So when we're stating, let me just have you highlight this. So when the p-value is less than 0.05, we do have convincing evidence to support HA. When it's greater than or equal to 0.05 or 5%, we do not have convincing evidence to support HA. Okay, so stating conclusions. Something else I would highlight. We're doing hypothesis testing in about 4 of the chapters we do in this course. So we'll be stating conclusions a lot with hypothesis tests. So make sure to highlight that. So always start off with your conclusion by comparing your p-value to 5%. So remember, our p-value was this 1% up here, okay? So recall from the simulation, our p-value was the 1%. So since 1% is less than 5%, so since my p-value is less than 5%, we do have convincing evidence that in 2009 and 2010, Rafael Nadal, has a greater or had a greater ability to play tennis on clay than other surfaces. Okay, so make sure you always start off by comparing your p-value to the 5% level and then stating whether or not we do or do not have convincing evidence and referencing your alternate hypothesis in context, okay? Now, what's a value for the p-value that would have caused me to make a different conclusion? So let's say our p-value was 10% instead. What would our new conclusion be? Well, we would then say, since 10% is greater than 5%, we do not have convincing evidence that in 2009 to 2010, Nadal had a greater ability to play tennis on clay than other surfaces. Okay, still referencing the alternate hypothesis in our conclusion, but this time we don't have convincing evidence because we said, hey, this wasn't special enough. It was likely to happen by random chance. So the last thing I want to just state and emphasize is that we always refer to our alternate hypothesis and our conclusions. Okay, so remember, just like in a judicial trial, they always reference guilt in their conclusion. We're always going to refer to HA in our conclusions for hypothesis testing. Okay? So make sure you keep that in mind when you are writing your conclusions tonight on your worksheet. Good luck, guys.